This is Geometry, Semester 1. This is Unit 1, Shapes, and Lesson 6, Circles, Degrees, Practice. It's on creatormath.com under the Geometry tab. You might have to type in creatormath.weebly.com to find it in Google. It says copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So just to model that quickly, here's creatormath.weebly.com. Homepage looks like this. Just so you know, all of the composition book stuff is on this first page here. And the home page, just scroll down until you see composition book and a picture of it, and then follow everything under it. All right. Otherwise, we're going to the Geometry tab where all the notes are and the videos and the vocab and etc. Right. So this is the Geometry tab. Here's the PDF with all the vocabulary you'll need for those assignments. There are videos for the vocab, some of them. And this says Semester 2. Let's go down. We want to find Semester 1. We need the correct semester here. There we go. Semester 1. This table of contents, this should have been copied onto your pages 2 through 6 of your composition book a while ago. If not, do it now. You're going to copy all these things on the table of contents into that pages 2 through 6. We are looking for shapes. Right, shapes 0, 1, and we're also looking for what unit 6 on circles. So we go to shapes and then we go down to 6 right here, and it's got the same title, Circles and Degrees. It goes on this page of your comp book, the notes. Please don't use this video, but go back and find the original on the website to know what pages are accurate for your semester. By the time you watch this, it will be different. So click notes, and the video solution will be here too, but click notes for now. Sometimes I have to load it twice. So if it doesn't load, like, oh, it did. Okay, so I did it once, but sometimes it's twice. So circles, degrees, the fact that a circle has 360 degrees. Okay, so let's see. Fact, a circle has 360 degrees because humans defined it to be so. So the Mesopotamians are credited with the 360-degree circle. They defined it and passed the definition to the Egyptians, from whom we have adopted the definition. So that's why we have 360 degrees in a circle, you guys. We just made it up, basically. And once we defined it, now we just use it as a rule, right? And that's kind of the difference between a postulate and a theorem. A postulate is a rule, oftentimes that we made up, a definition. And a theorem is a proof using postulates and definitions to prove it. So how to measure angles? We use degrees. Degrees are a made-up measurement system for angles based on fitting 360 degrees into a circle. So if we do a quarter of a circle, we have 90, 180, 270, and 360. That's the way a circle breaks down. This is the interior angle here, 90, and there's also an arc out on the circle, and that they can have an arc angle and an interior angle. Pi is the fantastic ratio, which is the fraction of the circumference of a circle divided by the diameter of the circle. So we'll see circumference is around the outside, and the diameter is the distance from side to side or circle to circle through the center, and it is pi, Pi, the Greek letter and alphabet letter, and is equal to circumference divided by diameter. You learned probably in middle school that that ratio was 3.14. It's actually 3.14159265, etc. And that continues forever. So as we get to high school, we start to use just pi. We don't even trade it out for 3.14 because 3.14 is not that accurate. There's different ways to create a circle. It's a set of points equal distance from one point called the center. That means if you just took a dot, 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 and went all the way around the circle, you'd create the circle. So the circle is not this area in here. The circle is this thing right here. That is the circle. Another way is to draw squares and to slightly rotate them. And as you draw enough of those, you start to get this round shape in the middle. And the round shape is technically composed of very small flat surfaces, if you think about it. So if we do an infinite number of squares, then it starts to become less flat on each of those components and more round. A circle is a set of all points which are an equal distance from a single point called the center. Degree, the unit of measurement for angles. The symbol is the degree symbol is the small circle in the superscript position. Circle, set of points equidistant from the center. Number of degrees in a circle, 360. Circumference is the distance around a circle. We say perimeter for other shapes, but when we talk about a circle, we say circumference. So the center is the point in the middle of all the other points that make up the circle. Pi is the fraction of circumference divided by diameter, and for every circle, no matter what the size, it comes out to be this wonderful ratio of pi, 3.14159.265, and on it goes. That's all I've memorized is up to 265, right? I've had contests with my students before, and they've memorized hundreds of digits, so it's an amazing thing. How many degrees? So this is 90. The square down in the center says 90 degrees. This is 180 because it's a straight angle. This is acute. This is acute, this is acute. So if I had to guess, I might guess this at, I don't know, this at 30 degrees, this at 45 degrees, and this at 60 degrees. And I'm just completely guessing. I don't know what it actually is. Here we talk about going around a circle, and this would be a major arc out here, and this would be a minor arc. All right, check the notes, put these in your comp book, and use them to help you with the problem set. So let's look at this problem set. So given the following figure, what's the measure of angle ABC? So let's look at angle ABC. This is an angle symbol, first of all. So you can say angle ABC. We just trace it through. Start at A, go to B, now go to C. Well, this is a straight line. The number of degrees in angle ABC is 180 degrees. Sometimes it helps students to just imagine if this were a smaller angle and you just kept opening it up until this became here and it was straight line now, then you'd be at half a circle, right? 180 degrees is half of 360. A straight angle, or angle ABC in this case, is a measure of 180 degrees. Given the following figure, what's the measure of ABC? So now we've got ABC. So the problem here is that if you trace through this thing, are they talking about this angle here or this angle here? This is called a minor arc. ARC, arc, and this is called a major arc. So angle ABC can define either of those. It could define this one, the minor arc, or it could define this one. Now, the fact that you're looking right now and you're probably going, just look at it, this is a darker, this is bolder darkness, I guess, whatever you say. So they're talking about this larger angle. So this is going 90, 180, 270. Piece of cake. If they were asking for the minor arc, it would just be 90 because that would complete out the circle. We love the 360-degree circle because it creates such an interesting way to look at angles. It creates the 30, 60, and the 90, and it creates the 45, etc. So given the following figure, we're going to see that in this lesson too. What is the measure of ABC? So now we're going here. So they want this measure right here. What's this angle? Well, we're going to guess. So look, if this whole thing is 90, and if this is 45, that's half of it, half of 90. That would make this probably 30 degrees, and then right here would be another 30 degrees in, which would be 60 at this point, right? So if you started here going this way, you'd go 30, 60, and then 90 by the time you hit here. And that's what this lesson is trying to get us to start to think about. We love the 30, the 45 degrees right here, and the 60 degrees right here, and then we get to the 90 here. And this would start at 0 going in this direction, right? If we started to go in different directions, things can be more interesting because circles go round and round and round, and that's a lot of fun. But so I think this angle right here, 30 degrees. We're just going to eyeball it. And that's what they want us to do. They want to start to think about that. All right? Given the following, here's ABC here. It's a straight 90, you guys. 90 degrees. Given the following figure, what's the measure of ABC? So all of this is ABC. So this looks like, right, it's half of this, right? It looks like this line here is at a 45-degree angle. That's where we get that, by the way, because it splits the 90 right in half. That would make 45 on this side, 45 on this side. And if you added them together, you'd get the 90 of this right here, quarter circle. So I'm pretty sure this is 45. It may not be perfect, but look at my answer choices, right? Is it 30, 90, 60? No, no, no. That's my best choice. Remember, multiple choice always tells you to pick the best answer choice available. and I feel like us test takers put that in case we make a mistake. That way, just pick the one that's closest. All right, so a little bit of inside information. So I think this now, ABC is going here. Here was 30. Here in the middle was 45. So I'm pretty sure this is 60. And that's where they're headed with this whole thing. That would make this 90. So we've repeated this a bunch of times. 60 degrees. It's not 45, it's not 30, and it's not 90. So 60 degrees looks like my best option. We love 30-degree angles. We love 60-degree angles. We love 45-degree angles. And we love 90-degree angles. Love them. All right. So as a geometry teacher telling you to pay attention to certain angles, those are the ones you pay attention to. Given the following figure, what is the measure of angle ABC? So this is just straight this way, right? 90 degrees. And we also call a 90-degree angle a right angle. Right. Given the following figure, what is the measure of ABC? So here's ABC. They want to know this angle right here. Well, I would argue if it were more like this, it would be at 45 degrees. If it were more like this, it would be at 60 degrees. If it were this, it'd be at 90 degrees. So I'm going to assume they're headed toward telling us this is 30 degrees. Look at the answer choices. It's not 60, it's not 45, it's not 90, it's 30. Given the following figure, so this to me, like if I completed the 90 here, this looks like right in the middle, 45. Right in the middle of a 90 would be divide 90 by 2. It would be a 45 here and a 45 here. The total distance across here, angle-wise, degree-wise, would be 90. So halfway there, 45 degrees. All right, given the following figure, what is the measure of ABC? So this one looks like if we go through the pattern here, we had a 30 somewhere here, 30 degrees. We had a 45 somewhere here. Makes sense that this is 60 degrees, and then if we just completed the 90, that might help our eye see that this is in the middle, 45, and these are a little bit halfway between those, right? The 60 and the 30 are halfway between the 45 and the base angle of the, what would it be, horizontal or vertical there. So let's go for 60 degrees. The others I don't like, they don't make any sense, so 60 is our number. So given the following figure, the ratio or fraction of circumference to diameter. So circumference divided by diameter is what famous understanding? I like that. More than one answer may be appropriate. That's interesting. What are my answer choices? Okay, I get it. Pi is correct. Pi is correct. And pi is correct. So pi can be the symbol, the Greek symbol for pi. Or actually, this symbol was created by a mathematician, and I forget what year, but back a couple hundred years or something, somebody just said, and I forget his name, you can Google it for me, please. I'm sorry, I don't have that on the tip of my tongue. But we named it pi, a certain person did, and he gets credit for it. And then pi would be the name of the Greek letter that it represents, and then 3.14159265359 ... which three dots means it goes on forever. It is an irrational number, and it is actually proof of forever because it never ends. Pi never ends, and therefore we know that some things in the universe never end. Wow, proof of forever right there in pi. So pi equals circumference divided by diameter. Circumference is the distance around the circle, on the circle, right? Start here, go around that distance, measure it, like cut it in half and unroll it into a length and then measure it. And then diameter is from circle to circle through the center of the circle, call it diameter. So circumference divided by diameter produces this ratio. And we, in high school, we're just going to leave it pi. So if we have like 5 pi, we're not going to actually use a calculator to multiply 5 times 3.14. It's less accurate. It's far more accurate to just say 5 pi and leave the pi in the answer. Make sure you are matching up the title of the lesson. It's Geometry Semester 1, it's Unit 1, Shapes, and it's the 6th lesson, Circles, Degrees, Practice on CreatorMath.com under the Geometry tab. Hope this helps.